Hello students, I welcome you all to the quick solution of All India AIATS test series for JEE Mains 2020, test number 4, code A and B, physics, test dated on 17th of November 2019. Let's straight away start with the question number 1. Here in question number 1, a radioactive sample A having an activity A0 has twice the number of nuclei of another sample B which has activity of 3A0. The half-lives of A and B can be. We need to find out the half-life of A and B. If I'm taking the active nuclei of B to be N, the number of active nuclei of A would be taken as 2N, and here NB, as I said, it is N. It's been given the activity of A is lambda A into the active nuclei, that is 2N, and similarly the activity of B that's been given to be 3A0. It should be written down as lambda B into N. Taking the ratio here, we are getting the answer as 1 by 3 would be equal to lambda A lambda B into 2, or I would say lambda B divided by lambda A would be 6. What we know here is half-lives of radioactive sample would actually be inversely proportional to the rate constant. So I would say T half of A and T half of B would be equal to 6. Taking this part as the reference, here we are getting the answer as the ratio of half-lives of A and B could be 6:1. So option 4 seems to be the correct answer, or most appropriately matching answer. Now let's take on to question number 2 here. In question number 2, a metallic sphere of radius 2 cm and work function 5.2 electron volt is under constant illumination of 200 nanometer wavelength light. Maximum number of photoelectrons emitted from the sphere is nearly. We need to find out the maximum number of electrons that can be emitted from the metal sphere. Well, the energy of the incident radiation, I would say it is HC by lambda. Putting the value of lambda to be 200 nanometer, this answer approximately comes out to be 6.2 electron volt. Well, you need to find this answer by calculation. So the maximum kinetic energy of the electron that would be emitted from the surface, I would say it is 6.2 electron volt minus 5.2 electron volt, that was the work function, it is 1 electron volt. So what we need to find is the total number of photoelectrons emitted from the surface. If the last electron would be emitting, if it is able to overcome this much of the energy, I would say, then the electron would be able to come out from the surface. So if N is the total number of electron, N into E square divided by 4 pi epsilon naught R, it must be equal to 1 electron volt of energy. Or N, it is this E would cancel out, we shall have here as 1 by 4 pi epsilon, this one, into R divided by E. On calculation, we get this answer approximately to be 1.4 into 10 to the power 7. So here for question number 2, option 1 is the correct answer. Now let's see the question number 3. In question number 3, a proton is fired towards a fixed nucleus having charge 60 E, where E is the electronic charge. It makes a closest approach of 15 femtometer to the nucleus. The de Broglie wavelength of proton at its start is, if this being the nucleus, whatever the distance it would be taken as almost a very large distance from the nucleus. So if it is having only the kinetic energy at initially, so I would say 1 by 2 mv square must be equal to the potential energy it must have at a distance of closest separation. It would be total charge inside the nucleus was 60 E into the charge of this proton is E divided by 4 pi epsilon naught, and the distance was 15 into 10 to the power minus 15 meter. So this portion would be V square would be 60 E square into 2m divided by 4 pi epsilon naught into 15 into 10 to the power minus 15, and this is m square, I would say. So square root of this much of the portion, square root of this much of the portion would be equal to the momentum of the system. So taking this value of momentum, the lambda we can write here as lambda to be equal to h by p. This is h here, and p would be the square root of this much of the portion, so it can be taken as 4 pi epsilon naught into 15 into 10 to the minus 15 60 e square into 2m. Well, this calculation is actually not needed here. We need to find out only the order of the answer here. So order of de Broglie wavelength, if we make a calculation, proper calculation, it comes out to be some around 10 to the power minus 14. So well, this is the way it has to be calculated, and the answer will be coming out to be 10 to the power minus 14th order. So here for question number 3, our answer is option 2. So that's the correct answer. Now let's take on to question number 4. Here in question number 4, two coherent point sources S1 and S2 are separated by a small distance d is equal to 5.2 lambda as shown. The number and shape of bright fringes obtained on the screen will respectively be. Quite an easy question it is. So if this being the screen, initially these two sources having distance of 5.2 lambda, once they will form the interference pattern at this point, this will have the path difference of 5.2. And now if we take some point around here, here and here, so the path difference would keep on decreasing. Let's say here the path difference becomes 5 lambda, here it becomes 4, here it becomes 3, here it becomes 2, here it becomes 1, and further 0. So by the time it reaches to infinity, the path difference will become 0. So definitely we shall not be having that particular interference pattern. So on a screen we shall have 5th order, 4th order, 3, 2nd order and 1st order. So effectively we will have this 5 different order of the interference pattern. But on the screen here also, this is the way the interference pattern will be formed. So what I shall say, total number of maximum would be 5, and we shall have the circular fringes in the screen. So for question number 4, option 2 is the correct answer. Now let's see the question number 5. Here in question number 5, in a hydrogen-like atom, electron makes transition from an energy level with quantum number n to another quantum number n minus 1. If n is very large, then wavelength of radiation emitted is proportional to. Here I would say that it actually changed from n to n minus 1. So the energy that will be liberated here, if I am writing down to be hc by lambda, then it would be delta E naught z square 1 divided by n minus 1 whole square minus 1 by n square, or hc by lambda would be taken as r hc z square. This part would be n square minus n minus 1 whole square divided by n minus 1 whole square into n square. So lambda would be, here it is n minus 1 whole square n square, and here n square minus n minus 1 whole square. So definitely the proportionality will be something like this one, r into z square. If n is very large, this portion will be taken as almost infinity. So in the numerator it is actually 4th order function, and in denominator we shall have a 1st order function. So I would say the lambda would be the function of n cube. So for question number 5, option 1 is correct answer. Well, here it is n square, and this portion n square will just be eliminated, and we shall be left with 2n, that is the highest order of the function. So that's the way I said the option 1 is the correct answer. Now let's take on to question number 6.